Hello and welcome to Basic Arithmetic Without a Calculator. I'm Elizabeth Johnson and this is Lesson 6, Converting Fractions to Decimals and Decimals to Fractions. Let's start out by looking at this equation. You've got 1/2 equaling 0.5. What we're looking at is two examples of a whole number that has been broken into two pieces. And so, to do the math, let's first of all have a good look at this fraction. You've got a bar with a number at the top and a number at the bottom. Well, that's a constant reminder that when we see a fraction, we need to divide. And when we divide a fraction, it's always the denominator or the bottom number that gets divided up into the top number. So let's have a go at this and see how you divide 2 into 1. Well, obviously, the 1 is a smaller number. And so it's going to be difficult to do the division if you don't know the tricks. Well, these are the tricks. Anytime there's a whole number, it is assumed that there is a decimal point to the right of that number, and we're going to put it there now. And after we've done that, well, we can put a couple of zeros here, all the zeros we want, and it will not change the quantity of that 1 because there's a decimal point there. In the same way, I could put zeros in front of this 2 and it won't change the fact that that's still a 2. This 1 still remains a 1. But these 3 zeros that are here are going to help me to do my division. So let's start by dividing 2 into 1. Well, it doesn't go, so there's going to be no whole number here. I'm going to put a 0, and I'm going to carry this decimal directly up. While I'm working, I'm going to try to keep it in mind that I want it to be tidy, and I want to keep the columns lined up above the columns so that I always know where I'm at. Now, if this 2 didn't go into a 1, there's still a remainder, and the remainder is 1. And remember, anytime there's a remainder, that remainder acts as if it's in the tens column. And here we've got a 1 in the tens column and a 0 in the units column, and that gives us 10. So we are now going to divide the 2 into 10. And there are, in fact, 5 groups of 2 and 10. And there are no remainders, so we don't have to do the rest of this work. We've finished now. The answer is simply 0.5. So let's have a look at another example. In this case, you've got 3/4. All right, and we're going to start out the same way as before. You've got the bottom number being divided up into the top number. 4 divided into 3. We'll put the decimal and maybe a couple of zeros that we can divide into. And we'll start by dividing 4 into 3, and we find that there are no whole groups of 4 in 3. So we'll carry the decimal up, and we'll carry that remainder of 3 over to the right, where it acts as a 10, turning this 0 into 30. So now there's 4 divided into 30. And 4 will go into 30 7 times, because 4 times 7 is 28, which gives us a remainder of 2, which goes in front of this next 0, turning it into a 20. So 4 goes into 20 how many times? Well, it goes 5. And this time there are no remainders. So if there's no remainders left, I don't have to do any more work. I'm simply finished with 0.75. Now, I've got a couple more, and each one's got a little bit of a different object. Now this one, it's 5/6, and it has got a repeater. So I'd like to show you how to work with repeaters. It starts out looking just like any other fraction. They always do. And so I'm going to start by dividing it as I would any other fraction. I'll put the decimal point, and I will put a couple of zeros to the right. And I'll start the division process by dividing 6 into 5, which will not go evenly. So I will put a 0 and carry the decimal up, carrying the remainder of 5 to the right. And that turns this 0 into a 5. Now I'm going to divide 6 into 50, and there are 8 lots of 6 and 50. In fact, 6 times 8 is 48, and so that gives us a remainder of 2. And that 2 goes in front of the next 0. So 6 into 20 goes 3 times, with again a remainder of 2. Now you see what's happening here. There's going to be zeros and 2's and it's going to keep going and going and going. This could go all day. I could have threes and threes and threes and twos and twos and twos. So what we actually do to show that this is repeating is we put a dot on top of the 3. And so the answer looks just like this, 0.8 and a 3 with a repeater. Okay, so that's what you do when you've got a repeating answer. Now, in this case, you've got 16 for denominator. So when you've got a denominator and you don't necessarily know the multiplication tables for it, the first thing you might want to do is start out by writing some multiplication tables just to help you with it, especially if you're in an exam and you're not able to use a calculator. This is one strategy you can use. 1 lot of 16 equals 16. 2 lots of 16, 32. And 3 lots of 16 would be 48. 4 would be 64. And 5 would be 80. 6, 96. And if I need more, I can write more in, but I'll just start with those. And as for this division problem, I'm going to do it exactly the same way I always do, except I'm going to use long division instead of short division. I'm going to show you how it's done. Alright, now it starts out looking the same, but what we're going to do is we're going to divide this 16 into 9, and when we find that it doesn't go, we put the 0, and we carry that denominator or the decimal point up. And this is where we part company from short division right here, because what I'll do next is I'll multiply 16 times 0, and whatever answer I get, I'm going to put beneath this 9. 16 times 0 is 0. And I'm going to subtract that from the 9. 9 minus 0 is 9. The second step of long division is to drop this next digit down to the right of your answer, and you get 90. So now I'm going to divide the 16 into 90. And when I do that, I look at my times table over here and I see that it'll go into 5 without going over. And now again, I'm going to multiply 16 times 5 and I get 80. And that answer is going to go down here below the 90. You're starting to see why they call it long division, because it can go very long. 0 minus 0 equals 0, and 9 minus 8 equals 1. And again, I'm going to drop the next digit down, which is a 0, turning this 10 into 100. Again, I'm going to divide 16 into 100. So I'll look over here at my multiplication chart and I see that it goes into 96 without going over. So I'll put the answer, which is 6, up at the top. 16 times 6, well, that's 96. And again, I will subtract. So really the difference is that I'm not working out the remainder in my head, I'm working it out on paper. So in this case, I'm going to use the add 1 to the top and 1 to the bottom method of subtraction, because you can't take 6 away from 0. But you can take 6 away from 10, and that answer would be 4. Now I've got 10 minus, or 0 minus 10, and I can't do that, so I'll add a 1 to the top and 1 to the bottom again. 10 minus 10 equals 0. And 1 minus 1 equals 0. And now for my little trick of dropping the 0 down to the right. And we ended up with 40. I'm going to divide 16 into 40. And we see that it will go twice. And 16 times 2 equals 32. So I'll have to subtract again. 40 minus 32, well, this 0 has to turn into a 10, so I'll add a 1 to the top and 1 to the bottom. And 10 minus 2 equals 8. And 4 minus 4 equals 0. I don't have to do the other ones. And I'll drop this 0 down. That gives me 80. And finally, I've got a 5 and no remainders. So 9/16 as a decimal looks like 0.5625. And we had to use long division to figure it out. So, with that in mind, let's have a look at how we can turn these decimals back into fractions. Well, here we've got some examples that we're going to do. We've got 5 steps that we're going to follow. First thing we want to do is we want to put this decimal into a fraction. So we're going to do it this way, 0.5, and do remember that anytime you put anything on top of a 1, it becomes an instant fraction. So it's already a fraction. But it's not okay to display a fraction while it's still got that decimal in it, and it's not okay to display it when it hasn't been simplified. So the second step is move that decimal point all the way to the right. And you're going to count how many places it has moved. So let's do that. I'm going to move this decimal all the way to the right, and I found that it had to move 1 place to get there. Now remember, in fractions, that anything you do to the top, you must also do to the bottom. So where would be the decimal in this one? Well, as we said before, anytime there's a whole number, it is assumed that the decimal falls to the right of that whole number. So there's your decimal. If I'm going to move this decimal 1 place to the right, like I did to the top, then I would put a 0 in here to fill that empty space. And that actually turned this fraction into 5 over 10. Now, we know what the last problem is. We have to simplify this fraction. And we can do that by seeing what number, the biggest number that can be divided into the top and divided into the bottom. And in this case, I'm going to divide them both by 5. So 5 divided by 5 is 1. And 10 divided by 5 is 2. And that's how 0.5 became 1/2. Let's try it again with 0.75. It's got 2 decimal places. It might be a bit more interesting. So we've got 0.75. Step 1, turn it into a fraction by putting it on top of a 1. Step 2, move that decimal point over to the right as far as it'll go. And in this case, it moved 2 steps to get here. So we'll move the bottom one 2 steps. 1, 2. There's the decimal point, and fill in the empty spaces with zeros. And that gave us a fraction of 75/100ths. And the final step is to simplify the fraction into its lowest terms. And to do that, you have to find the biggest number that can be divided into the top and into the bottom. And in this case, I'm thinking that number is going to be 25. So I'll divide the top by 25, and there are 3 groups of 25 and 75, and I'll divide the bottom by 25, and I end up with 4. And so 0.75 is the same thing as 3/4. Okay, now I've got a difficult one for you. We've got that monstrous decimal that we worked with before, and we're going to try to turn it back into a fraction. Now remember, we start by putting this decimal into a fraction. 5/625. We turn it into a fraction by putting it on top of 1. Second step, move that decimal all the way to the right. How many steps does it take? 1, 2, 3, 4. So if it took 4 steps to get over here, I'll have to move the bottom decimal 4 places. 1, 2, 3, 4. And we'll fill in all those spaces with zeros. 1, 2, 3, 4. And you might be horrified to see that you've got a fraction, which is 5,625, 5,625 over 10,000. You have got 10,000 for denominator, and it happens. This happens especially in your trade, and so it's good to know what to do with it once you get it. Now, I have got the awesome task of trying to simplify this very big fraction. And I'm going to have to really scratch my head and think about how to do it. And one thing I can see as a clue is there's a 25 at the top of the numerator, and there's 2 zeros or 3 zeros at the bottom of the denominator, which means that they can both be divided by 25, and that's exactly what I'm going to do. I'm going to divide the top by 25. I don't know if it's the biggest factor, but I do know that it'll work. So I'll start by dividing them both by 25, and then we'll see what we get when we're finished with that. Now remember, anytime you're doing a division problem and you've got big numbers, don't be afraid to take out the pencil and paper. 25 divided into 5,625. Well, I know my 25 times tables pretty well, so I don't have to write them out. I know that 25 will go into 50 twice, with a remainder of 6. And I also know that 25 will go into 62 twice, with a remainder of 12. Now this is what you do when you have a 2-digit remainder. You just write it in, and you've got 125 now. So 25 goes into 125 5 times. Wasn't as hard as I thought it would be. So you've got 225 for your top number. Let's work out the bottom number. 25 divided into 10,000. How many times will it go? Well, let's see, it won't go into 10, but it will go into 100. 25 goes into 104 times. So I'll put the 4 here. And because there's no decimal, I still have to divide each of these zeros. So now I'm going to divide 25 into 0, and I find it goes 0 times. And again, 25 into 0 goes 0 times. So the bottom number now is 400. And I can tell by looking at it, I can divide them by 25 again. So I'm going to do that. That means I could have had a bigger denominator, or a bigger common factor, but I didn't see it at the time, so I had to work it out. Now I'm going to take 225, and I'm going to divide that by 50. Or by 25, sorry. So how many 25s go into 224? Well, there's 4 of them that go into 100. So there's 8 of them that go into 200. And then there's 9 that go into 225. So it'll have a 9 on the top. Now, how many 25s go into 400? Well, if 25 goes into 104 times, and it goes into 208 times, so it must go into 416 times. So I finally had simplified my fraction down to 9/16. Now you will have some problems on your exam where you have to be able to do this. Luckily, I don't think you have any that are this big. I'm not quite sure. But it's good to know how to do this. So have a go at your exercises, get good at it, and I'm sure you'll do fine on your exam. And we'll see you back in the next video.